What's up, calculus students? We're going to do a new homework video for this lesson 4. We're solving differential equations that will involve logs and e's. And we learned about some exponent rules that we're kind of reversing to help us out. All getting us ready for the free response questions that we're going to have on our test and at the end of the homework that you need to do. If you're going to do them first, honestly. They're the important ones with all of the steps. Okay. Talk about how each question is worth 9 points, but the main part, which is finding particular solutions in the equation to the differential equation in the form y equals f of x, being the main part. When you're asked to find a particular solution to a differential equation, it really just means, take the antiderivative. Okay, sometimes when we don't see it in this form, we don't know what to do when we get to a free response, so just keep this in mind. And remember, to take the antiderivative, we need to separate our variables algebraically. I'm going to multiply by dx and divide by y. You good? You good?
Yeah. Something new came up with the Army thing. We got my medical documents back, and my recruiter sent them up for a complex medical screening so that I can get them waived. But it's going to take a couple months because they're so backed up from everything.
Months is a bad thing to hear.
Yeah, but it's gonna happen. It's just a matter of time.
All right, cool. Thanks.
Yep.
So we start with dy over y, which I probably want to rewrite as y to the negative first times dy. The two x's stay where they are. They might be in the denominator. Keep them there. Take the antiderivative of both sides. The dy will go away. The dx will go away. Remember that the power rule doesn't work for the negative first power, but it works for every other power. Log absolute is the antiderivative of negative first. X squared is the antiderivative of 2x. We could find c whenever we want, but we talked about in class how sometimes using exponent properties will help you put c in an advantageous position. C will be in the exponent of e. I'll show all the steps here. But we reverse the exponent rule, which you're used to using, like x squared times x cubed, you say is x to the fifth. We'll kind of reverse this to say, well, if it's x to the 2 plus 3, I can write it as x squared times x cubed. I'm going to take this sum in this exponent and write it as a product of e to the x squared times e to the c. Well, e to the c is just another c. We'll call it a c2. I'll take that c2 and I'll move it in front to be like a coefficient of e to the x squared. So e to the c1 is c2. We get this. To get rid of the absolute value, you make the right side a plus or minus, but what I'm going to tell you is that you can ignore this. E to the x squared is always positive. When we find c, we'll find if c is positive or negative correctly, which means we don't have to worry about selecting the correct sign. We'll just get the correct sign. The only time you have to worry about selecting the correct sign is when we take a square root. So when I plug in the 0.04, ignore the plus or minus, you will find that c has to be positive 4. 4 times e to the x squared will always be positive. Plug in an x, get a positive y. Make sure you write out your full solution. There's no plus or minus. If I plug in 0, I just get positive 4. Okay, that was an easy one to start with. The next one's another easy one. I got dy over y. I'll probably rewrite that as y to the negative first. We like to rewrite all of our exponents to be in the numerator. Careful about positives and negatives. When I take the antiderivative, dy goes away. The antiderivative of sine x, nothing crazy. It's just negative cosine x. Forgot to mention this, but don't forget your plus c right away. When you take the antiderivative, you need a plus c here. Don't wait to add the plus c later, or else it's not going to be in a good spot potentially. It needs to start in the right spot and then get moved to the right spot. I take e to the power, put c in an advantageous position. It is in the power of e, but then using the reverse exponent rule, we write e to the c1 as a c2. Absolute y equals c2 e to the negative cos x. Get rid of the absolute, make the right side plus or minus, but essentially ignore the plus or minus because you will find the correct sign of c2 will be positive. Now, when I plug in 0, 2, I get the following. 2 equals, again, ignore the plus or minus, you'll find the correct sign. E to the negative cos x will always be positive. E to the negative cosine of 0. That's e to the negative first. Now, there's different things you could do here to solve for c2, but they're easily done. You'll just divide by e to the negative first, or you can multiply by e. If you wanted to, you could rewrite e to the negative first as 1 over e to the positive first, and then you can multiply by e, but we're talking about this showing up on a free response question. It's okay if you divide by e to the negative first. Getting c2 is 2 over e to the negative first, or getting c2 is 2e when multiplying by e. Finish off by combining your c and your y equals equation. Y equals, I don't know, whatever you want, whichever one you had, 2e times e to the negative cos x. Now here's a situation where you might, on a multiple choice question, not see this answer. And this is where we kind of go forward with our exponent rules, where we'll keep the 2 down, that's fine. But e to the first times e to the negative cos x could be written as e to the negative cos x plus 1. This is acceptable, or 2 over e to the negative first is acceptable for free response. This may be the answer that you see on a multiple choice if this shows up on the multiple choice. This is a good one because we see x's in the denominator, which means you'll end up with dy over y. And then dx is going to stay in the bottom. So it's going to be 1 over x times dx, or dx over x. Regardless, you should have a negative first power for both x and y. Don't let this x just come up. Take the antiderivative and say it's 1/2 x squared. Like, make sure you keep it where it is. You didn't move x. X is in the denominator. It stays in the denominator. You get log absolute y, and we got log absolute x plus c. It's a great example of like exponent rules will help us simplify, but be careful when you simplify. When I take e to the power of both sides, it does not simplify to just be x plus c, because the entire right side stays in the power of e. So this becomes e to the log absolute x plus c, which I rewrite using exponent rules, reversed, as e to the log x times e to the c. E to the c1 becomes a c2. E to the natural log of absolute x becomes absolute x. So this becomes c2 times absolute x. It's not absolute x plus c2. We'll get rid of the absolute y by making this a plus or minus. We won't get rid of the absolute x. That'll stay, but it won't really matter. Again, you'll just kind of ignore them, but your answer should have an absolute x. I plug in 1, 3. And I get c2 equals 3. I get y equals positive 3 absolute x. Cool? This next one is a great one to do. If I'm going to star anything for like preparations for the test, like I'm starring this one mainly for the fact that we have this quantity in parentheses on the right side. Now, you like to distribute. In most math classes, we always distribute. Hold on, I gotta get the phone. All right. Why do I say this? Like, don't distribute. Don't distribute because it makes separating variables a lot harder. You'll see that later on for your response. Instead, just like multiply by dx, keep the 2x minus 3 in parentheses, divide by e to the y. Now, you get dy over e to the y, and you get 2x minus 3 in parentheses times dx. Now, let's talk about the left side. To take the antiderivative of e to the negative y, you're not going to use a log. A lot of people think you will, but no. What we like to do, like with all the other ones, is rewrite it so that things are in the numerator, whether it's a negative exponent or not. Here, like I would rewrite this as e to the negative y. This is important because it becomes a e to the parentheses antiderivative that I need to take. Now, remember, like the antiderivative of e to the x is e to the x. The antiderivative of e to the parentheses is e to the parentheses. Then we got Vegas. What starts in the parentheses stays in the parentheses. And then undoing Vegas's derivative, whether it's with a reciprocal. Here, since it's just -1, I just need a negative. So the left side is negative e to the negative y. Now the right side, a lot of people see the parentheses and think, oh, I have to take the antiderivative of parentheses. But it's like, if I didn't have the parentheses and I just said, guys, take the antiderivative of 2x minus 3, what would you do? You would just take the antiderivative of 2x and say it's x squared, and you take the antiderivative of 3 and say it's negative 3x. That's what I want you to do here. You could make a mistake if you do it the other way. You would get the right answer doing it the other way for this one. However, if this was something other than x, it doesn't work. Don't forget to take the antiderivative. A lot of people would rewrite this as e to the negative y and then leave it as e to the negative y. Because, doing the simplification step, they think as being the antiderivative, but it's not. Okay, I'm going to take the opposite of both sides to get rid of this negative. So that becomes a negative x squared, a positive 3x. You can write this as negative c1, or you could just write it as a new c2, which I'm going to do, where c2 is equivalent to the opposite of c1. So plus c2 minus c1, doesn't matter. We're going to end up with the same stuff. We could solve for y by taking the natural log of both sides, but then to find c, because that would be trapped inside the natural log, I'd have to undo that. So like, this is where I say, hey, just pay attention to when is a good time to find c. I think a good time to find c is now. Kind of wish I had things flopped, 3, 0, but I don't. I have the point 0, 3, which means e to the negative third is equal to 0, 0, c2. That's fine. We'll just leave it. So I got e to the negative y equals negative x squared plus 3x plus e to the negative third, which I can write as 1 over e cubed. I will then take the log of both sides. When you take the log of the right side, it's not log, log, log. It's the log of the entire right side. I get negative y equals the log of this stuff with the correct c2. And then I solve by taking the opposite of both sides. You'll just take the opposite of the log. Okay. This problem shows up on your quiz and on your test. It's a good problem that challenges kind of everything. We will multiply by dx, but actually before that, sorry. It's like, how do I separate my variables? We talked about it in class. I showed you in class. Told you it's gonna be on the test. You reverse that exponent rule. Now you multiply by dx and you divide by e to the y. We saw it earlier if you have e to the y in a denominator, you should rewrite it as e to the negative y. All of this work is just setting it up to then take the antiderivative. Again, e to the negative y is antiderivative is negative e to the negative y. You start with e to the parentheses, Vegas and undoing Vegas, and we have e to the x plus c. Probably get rid of this negative, making this a c2 compared to c1. You could have minus c1 or you could have positive c2. It's up to you when you want to find c. If I took the log of both sides, I'd have to undo it to find c. I could find c now, plugging in 0, negative log 3. What does that look like? Well, it's not that bad because it's e to the opposite of negative log 3, which is e to the positive log 3, which is 3. And over here, I have minus e to the 0 plus c2. Order of operations, exponent first, then take the opposite of it. I get c2 is just 4. So I'm here. I got e to the negative y equals negative e to the x plus 4. I'll take the natural log of both sides, put everything on the right side inside a natural log. Take the opposite of both sides to solve. Okay? You can't simplify the log of negative e to the x because it's negative e to the x plus 4. Don't forget, if you don't have x's, no x's here, don't worry. Leave the constant, no matter where it is, leave it. Move the y's. Let's see what we have. dy over y equals just negative 3 dx. Well, that's fine. I can take the antiderivative of negative 3. It's just going to be negative 3x. We antiderive. We got log absolute on the left side. We get negative 3x plus c. We go through our exponent reversing. We take e to the power of both sides. That becomes e to the negative 3x plus c, which becomes e to the negative 3x times e to the c. We reverse the exponent rule. E to the c1, we're going to say, is a c2. And I get absolute y equals, so I'm going to move the c2 in front, c2 e to the negative 3x. Plus or minus gets rid of the absolute. When I plug in 1, 3, ignore the plus or minus because we will find the correct sign. So another good example, you can divide by e cubed. You can divide by e to the negative third, or you can multiply by e cubed. You can rewrite e to the negative third as 1 over e to the third, multiply by e cubed, or you can divide both sides by e to the negative third. Don't care. You either have that or that. You can either have this or keep the 3, combine these two, going in the normal order, but as a sum. The next two are great ones because you have to remember about antiderivative of parentheses where there's an ax plus b in it. Both of these involve Vegas and undoing Vegas's derivative. Don't forget about that. Again, don't distribute when you see parentheses. Multiply by dx, divide by parentheses 3 minus 2y, giving you dy over 3 minus 2y, and giving you sine 2x dx. Before I take the antiderivative of this, it's helpful to rewrite things as something in the numerator, in this case as a negative first power. And then when we take the antiderivative, okay, we got to take the antiderivative of a negative first power, which is log absolute parentheses. Then we have Vegas. Then we have to undo Vegas's derivative. Vegas is what starts in the parentheses, stays in the parentheses. So I'll have log absolute 3 minus 2y. That's Vegas. Vegas's derivative is negative 2. I need to undo that with a negative 1/2. Sine 2x, same deal. Start with the antiderivative of sine parentheses, which is negative cosine parentheses. We got Vegas. We undo Vegas's derivative. So what starts in the parentheses stays in the parentheses. The derivative is 2. I need to undo that with a 1/2. So I'll put a negative 1/2 in front. This is great because we have a negative 1/2 on both sides. I'm going to multiply everything by negative 2. When I multiply everything by negative 2, the negative 1/2s go away. C1 times negative 2, you can write as negative 2C1, or you can write that this is a different C. It's a C2. Take e to the power of both sides. This is going to be gross, but it'll work out. Giving me 3 minus 2y equals, I'll show it, e to the cos 2x plus C2 becomes, we're going to have a C3 for the first time, e to the cos 2x times e to the C2. E to the C2 is a new C. It's a C3. So I'll write this as C3 e to the cos 2x. Get rid of the absolute value, make this a plus or minus. Again, it's just going to be ignored. When I plug in 0, I should get 2. Cosine of 2 times 0 is the cosine of 0. The cosine of 0 is 1. C3 equals negative 1 over e. Now, you got rid of the absolute value. You found the correct sign. But you still have to solve for y. Subtract 3, divide by negative 2. Might not look great, but it's correct. And maybe multiply the top and the bottom by negative 1 to make everything a positive if you wanted to. Okay. Same thing here. Don't distribute, just divide. You probably could do this, but if you want to, rewrite. Now take the antiderivative. We did it. Antiderivative of parentheses to the negative first is log absolute parentheses. Vegas. Undo Vegas's derivative. I need a negative because the derivative of negative y is negative 1. Take the opposite of everything. That becomes minus C1 or a C2. Put C in an advantageous position. If you've done it enough, you're probably good that this will be a C3. We start with negative C1. E to the negative C1 is C3, or negative C1 is C2. E to the C2 is C3. Get rid of the absolute value, make this a plus or minus, ignore the plus or minus because you're going to find the correct sign because e to the negative x cubed has to be positive. I get 1, 1. Oh, that's fun. I don't think I should get 1, 1. Subtract 1, take the opposite of both sides. Maybe combine these two as that. Subtract 1. Take the opposite of both sides. There's your answer, or various forms of that. And again, if you write it as like -1 divided by -1 and leave that, I got to give you full credit. Okay? Now, what are your free response questions going to look like? Just like this. 3 or 4 parts, some review, mostly from Unit 4, probably going to involve a slope field, and one of the parts is going to be the big part, finding the solution to the differential equation, which means taking the antiderivative. Find the particular solution to the given differential equation. Is this part C? This is worth 5 or 6 points. Okay? Don't do it right away unless they ask you to do it right away. Like find the part that asks you to solve the differential equation. Part A just asks you to find a slope field. All right, so we got y equals 2, y equals 1. I like doing this. Y equals 0. I got x equals 0 and x equals 2. If y equals 2, the top is 4. If x equals 0, the bottom's -1. If x equals 2, the bottom's 1. So I got -4 and +4. They excuse me, probably should be steeper. If y equals 1, the top is 1. If y equals 0, the bottom's -1. The bottom's 1. So this is -1. This is +1. If the top is 0 and the bottom is -1, we get 0. If the top is 0 and the bottom is 1, we get 0. Okay, cool. Now again, we plugged in points to get slopes. That needs to be used for like part B, right? An equation for the line. Now, this is where it gets confusing because everybody reads this like, let y equals f of x be the particular solution to the given differential equation. People are like, I got to take the antiderivative. Got to take the antiderivative. No, not yet. Keep reading. It says write an equation for the line tangent to the graph of f. You don't need the graph of f. You don't need the equation. You don't need the antiderivative to find the equation of the line tangent. Remember, for the equation of a line tangent, you just need a point and a slope. The point's given to you, 2, 3, 2, 3, this point. Oh, you already found the slope is 4. But like, how do you find the slope? The slope is your slope generator at the point. Like, confirm. Oh, it's not 2, 3. Never mind. It's not 4. 2, 3 would be 9 over 1, which is 9. Okay, so plug in your point to get your slope. Y minus 3 equals 9, x minus 2. You do not have to solve for y. This is fine. However, it is helpful to solve for y to approximate points on your curve using a point on a line. The y's on your line will approximate the y's on the curve. Y of 2.1, the point on the line is approximating the point on the curve. You are allowed to leave this as your answer. This is unsimplified. It is correct. If you want to simplify, you can. Now, sometimes they'll ask you, is this an over and under approximation? Remember, the second derivative being positive under, the second derivative being negative over. Also remember, and this is tricky and this shows up on a free response, when you take a derivative of a derivative, you might have to use a rule, and whenever you take derivatives of y's, you'll get a dy dx. If I took the derivative of this to examine concavity, I would have to use the quotient rule. I'd have 2y dy dx. It's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Around the point 2, 3, this is 9. This is positive. This is going to be positive. This will be 9. This will be bigger than 9. This will be positive. Like you could kind of do that math to figure out that the second derivative is positive and that the approximation's under. But what I need you to remember, or you're going to lose a point, is when you're taking the derivative of y's and x's, use your rules and don't forget about dy dx's. Now we're finally in part C, where we're actually taking the antiderivative. Here's how the points are distributed. 1 point for correctly separating your variables. I love this example because we've been doing logs, 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 logs. We are used to x's being in the denominator or being in the numerator. This time we have an x minus 1 in a denominator. It stays there. We got y squared on the left after dividing. Be careful. The antiderivative of the left side does not involve a log. The antiderivative of y to the negative second is y to the negative first times negative 1. The power rule works. The antiderivative of 1 over x minus 1 is log absolute x minus 1. It's log absolute parentheses, it's log absolute, and then we got Vegas, and we're undoing Vegas's derivative. So like there's Vegas, and undoing its derivative is just a 1. Take the opposite of both sides, this becomes a C2, it's minus C1. Flip both sides. Remember, it's 1 over y. You could flip both sides if you wanted to. I'm actually going to wait one more step. I'm going to find C2 with a 0.23. 1/3 equals negative log 2 minus 1 plus C2. The log of 1, you need to remember, is the same as the log of e to the 0, which is 0. That will help you figure out C2 is just 1/3. Okay. Now, again, we've seen this before. Don't try to be fancy when you're solving for y. If I wanted to get y in the numerator, I'd flip both sides. I'd take the reciprocal of both sides. Well, that means the entire right side ends up in the denominator. I see a lot of students turn this 1/3 into a 3. No, don't do that. It's not right. It's in the denominator. It's not plus c on the outside. It's in the denominator. And if you wanted to do anything, you can multiply the top and bottom by 3 to get 3 over negative log x minus 1 plus 1. But this is fine. You get full points. Let's go over the points. +1 for separating your variables, +1 for each correct antiderivative, +1 for finding the correct c, making sure you have it in the correct spot, +1 for solving. If I were to give you 6 points, I would probably include the fact that you involve a c and you attempted to find it. So, like, lots of points to get. Total 9. This was worth 1. This is worth 2. Or this is probably worth 2. This is probably worth 2. Or this is worth 1. This is worth 3. Okay, less, lot more. Same thing. This is 3 parts. And A, B, and C. This is probably worth 1. This is probably worth 2 or 3. This is probably worth 5 or 6. Excuse me. You don't have to solve the differential equation until part C. Part B does not involve solving the differential equation. It just involves finding a tangent line. Unit 4 comes back. Part A says, here's the slope field. I created it for you. What would a solution look like through the point 0, 1? Here's the point 0, 1. All you have to do is be like, okay, this equation fits my slopes. Whatever my solution is, it's going to look like that if I graphed it. That's it. Part B, tangent line equation. Y minus y1 equals some m times x minus x1. We need to find my slope at this point 0, 1. Now, they kind of show you what it is. It's that positive slope, but don't guess, figure it out. Plug in 0, 1, you get 3 minus 1 times the cosine of 0, which is 2. 1 point probably for that, and then 1 point for the approximation. Y of 0.2 is 2 times 0.2 plus 1. Leave it. That's fine. That's fine. I'll give you points. Try me. I'm going to give you a point if you leave this. What is bad is if you try to simplify and do it incorrectly. Now let's solve. Okay, great example. Because we're dividing by the parentheses, we don't distribute the parentheses. Again, you're probably getting used to this if you're actually doing the work, where you're going to rewrite this immediately as 3 minus y to the negative first power. Oops. You take the antiderivative. Don't forget to take the antiderivative. Antiderivative of negative first power is log absolute. We got Vegas, and we have to undo Vegas's derivative. Don't forget about lesson 2. Antiderivative of cosine of sine. Don't forget a plus c at the right moment. I'm going to get rid of the negative. That becomes a c2, or it's minus c1. It doesn't matter. I will put c in an advantageous position to find by taking e to the power of both sides. I get absolute 3 minus y. Go back and see the steps so you know this becomes a c3 e to the negative sine x. You're okay to not show all the work to get this step. Just make sure you do it correctly. You get rid of the absolute value. You make this a plus or minus, but you can ignore the plus or minus when you're finding this C3. You have the point 0, 1. This is really where finding C is very easy to do. If you have e to the 0, that's just 1. C3 is positive 2. You don't need the plus or minus. You get the correct sign right here. Has to be positive 2. Subtract 3. Take the opposite of both sides. However you want to do it, do it. You could even divide by negative 1 and leave it, or you could just take the opposite of both sides. 1 point, 1 point, 1 point, maybe 1 point. Definitely 1 point, definitely 1 point. Yes, this is a great one. Great one. This covers it. I think we're going to be ready for the test if we've done this one with one exception. Oh, we have one more after this, right? Yeah, good. Good. This one. Yo, heads up. We're covering everything. I'm adding something to part A. This is an over or under approximation. Okay, cool. Write the equation of the tangent line of the point 1, 0. Use it to approximate f of 1.2. Is it over or under? Don't forget, you got to find the slope. E to the 0 is 1. 3 minus 6 is negative 3. Y of 1.2 is going to be negative 3 times 1.2 minus 1. Leave it. Leave it. If you put it as negative 0.6, great. Did you have to do that? No. All right. Heads up. Over or under. You'll have this on the test. Second derivatives. If you take the derivative of e to the y times 3x squared minus 6x, you have to use the product rule. The derivative of the first is e to the y times dy dx. times the derivative of the second plus the derivative of the second times the first. Now, doing some of the work we've already done, we know e to the y is positive. We know dy dx ends up being negative. But we know 3x squared minus 6x, this part, is also negative. If I plug in 1, I'll get something 0 or something positive. It's like tough to say, but let's just say like it was obvious that the second derivative was negative. And it will be obvious whether or not the second derivative is positive or negative if you do it correctly for the question that you'll be asked on your test about over and under approximations. You say since the second derivative is negative, approximation has to be over. Okay, good review. Now, why do I like this question? Again, we have these parentheses. If you try to think of this as a composition and like take the antiderivative of the outside, you're going to get it wrong because it's an x squared on the inside. Just take the antiderivative of 3x squared minus 6x is what I'm trying to get you ready for. Let me just show you what that looks like. I'm going to divide by e to the y, which is multiplying by 1 over e to the y. I'm going to multiply by dx. I get dy over e to the y, which I'm going to write as e to the negative y dy. Ugh. And on the right side, I have 3x squared minus 6x dx. The antiderivative of the right side does not involve parentheses. It's really just the antiderivative of the multiple terms. It's not really a composition. It is a composition of the first power, but like, don't try to put a 2 and a 1/2 there. Just take the antiderivative of 3x squared, which is x cubed. Take the antiderivative of 6x, which is 3x squared. Add 1, multiply by the reciprocal, combine your coefficients. Negative e to the negative y. Don't forget a plus c. I'm going to take the opposite of everything. That becomes a C2, which is the opposite of C1. It's a good time to find C2 right now. Plug in 1, 0, because I know e to the 0 simplifies nicely. I'll get negative 1 plus 3 plus C2. So I get C2 is negative 1. Okay. So now I have e to the negative y equals negative x cubed plus 3x squared minus 1. I'll take the log of both sides. Again, finding c a little bit earlier here prevents you from having to undo logs and kind of use like just going back and forth with e to the power and log. You just like get it done. Take the opposite of both sides and you're done. The negative 1 is inside the log. It's not an absolute because I'm using a log to solve an equation. Absolute shows up when you take an antiderivative. All right, this was in our homework. We kind of started this in all of our classes. You will have a question like this. This is a great question because you will see something very much like this, including like something where they're going to give you a graph and they're like, could this be the graph? And this is tricky. Mostly tricky if you keep B's and T's. Now, what I told you in class is like, sometimes if you're not comfortable with different variables, which we really aren't yet, understand that B can represent Y and D can represent X. If you want to write something how like, let B equal Y, let T equal X, just put that somewhere and rewrite the entire equations with Y's and X's. You know, that's helpful. I'll show you two different ways, but like it is helpful for you guys to use Y's and X's. I know it. Okay. B is the weight. Y is the weight. X is time. The question is, for part A, and this is a great question, we're starting to go into real world situations, very much like a related rate steal. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Now let's think about this, guys. dB dt is a rate of change. It's how quickly B is changing. How quickly B is changing is how quickly the weight is changing. Okay. Or you change it to like dy dx and you're like, oh, that's the slope of the tangent. Or that's how quickly y is changing. That's the instantaneous rate of change of y. So the question really ends up being like, what are the rates of change when y or b is 40 and when y or b is 70? We will plug in 70 and 40. I get 1/5 times 30, which is 6. I get 1/5 when b is 40 times 60, and that's 12. This is 6 and this is 12. This is when the bird is gaining weight faster because dB dt is bigger at 40 than it is at 70. You could have done the same thing with y equals 40, dy dx, as long as you've established that they're the same thing, is larger at 40, y equals 40 than dy dx is at 70. Okay? Don't want the b's and t's to just confuse you. Now let's go to the next one. Find the second derivative. Use the second derivative to explain why the graph of b cannot represent the following graph. This is where like switching to dy dx is going to help you tremendously because of that y, because b is replaced by y. Why do I mean that? When you guys take the derivative of b, a lot of times you will just say the derivative of b is 1. No. If I say what's the derivative of y, hopefully you guys would say it's dy dx. Guess what? The derivative of b is dB dt. So replacing things with x's and y's, for now, maybe in the future we won't have to. Very helpful for now. If I take the second derivative, now, what are you going to do here? There's two things you could do. You could use the quotient, the product rule, or you could distribute just to make the derivative easier. I told you not to distribute. And if you're like, I don't want to distribute, don't. Then here's what the product rule would look like. The derivative of 1/5, which is 0, times 100 minus y, plus the derivative of 100 minus y is negative dy dx. The derivative of y is dy dx. The derivative of negative y is negative dy dx times 1/5. Now, if you did that after distributing, you get 20 minus 1/5 y. The derivative of negative 1/5 y is negative 1/5 dy dx. Switching b's and t's to y's and x's will help you make sure that you have this derivative in your second derivative. Okay, now, what is this? Well, you can tell that between 20 and 100 for y, for b, between 20 and 100, dB dt or dy dx is positive. So we have a negative times a positive times 1/5. The second derivative is going to be negative everywhere, so long as y is between 20 and 100, which the graph looks like it is. You could kind of figure this out if you like thought about it for a while. Or you could have plugged in like, this 0.020 plug in 20 into dy dx, plug in 20 into dy dx, see that it's positive, and kind of just go from there. And so you have a negative times a positive times a fifth, negative. Now, what does that mean? That means the graph of y, which equals b of t, must be concave down. The graph is not concave down. Okay? This is so helpful, and you'll have a question on your test that has y's. Don't forget the derivative of y involves a dy dx or a dy dt. It might not even be b. I think I give you y, and you got to make sure you take the derivative correctly. There's a couple quick tough parts on one question. Just do your best to understand a derivative is a rate of change, and a second derivative is a rate of change of a rate of change. Okay? Like maybe just quick little review. dB dt is rate of change of b. If dBt is positive, b is increasing. D squared b over dt squared would be the rate of change of the rate of change. It's how quickly the rate of change is changing. Part C. If you change it to y's and x's, maybe you're better off than if you kept it b's and t's. If you see this, don't distribute, keep the parentheses, move the y's or move the b's, move the x's or move the t's. Be the same thing here. 1 over 100 minus y dy, or dy over 100 minus y, equals, leave the 1/5. Why? When you take the antiderivative of 1/5 is easily done. This is the same as parentheses to the negative first power. Antiderivative of the negative first power involves a log. Vegas, undo Vegas's derivative. Include a plus c. Take the opposite of both sides. This becomes a c2, or it's minus c1. Take e to the power of both sides. We get a c3. We have the point 0, 20. Solve for y, subtract 100, divide by -1. Or show the divided by -1. This is acceptable, provided you've established somewhere on your paper, let b equal y, let t equal x. If you want to go back, you'd say b equals -80 e to the -1/5 t plus 100. In the future units, we're going to start using more different variables, and we need to just be comfortable not using y, not using f prime, using x prime, using v prime, stuff like that. Okay? All right. Good homework. Preparing you for the test. I'll see you out there.